Okay, we're going to start out with natural log function, finding the derivatives. So first of all, defining the natural log, reviewing the properties, and calculating the derivatives. Definition, calculus, and algebraic definitions are right here. Hopefully my pen, there we go. And that you don't need to know, it's just more of an explanation for it. ln of x equals log base e of x, that's the algebraic one you know. Calculus, ln of x equals the integral from 1 to x of 1 over t dt, or the area under the curve from 1 to some x of the function 1 over t. Properties you should know from pre-calc. Ln of 1 is 0 because e to the what power equals 1, that would be 0. Ln of a times b is ln of a plus ln of b. Ln of a over b, ln of a minus ln of b, and then ln of a to the n is n times ln of a. We did review that at the beginning of the year as well, so hopefully it is fresh in your mind. Alright, so expanding logarithmic expressions. So something like ln of 10 over 9, just can rewrite that, ln of 10 minus ln of 9. When it's something like this, that is 3x plus 2 to the 1/2 power, so you can write it 1/2 ln of 3x plus 2. Okay, ln of 6x over 5, you can do ln of 6x minus ln of 5. You can also split this up if you want, ln of 6 plus ln of x minus ln of 5. Okay. Oh boy, this one. So two things. I'm going to do the quotient rule first. So ln of x squared plus 3 squared, so that 2 can go in front, minus, this is a product, so ln of x plus, this is x squared plus 1 to the 1/2, so 1/2 ln of x squared plus 1. Okay, and that is just separating it out, just a little bit of review there. So, now to the calculus part. Derivative of ln of u is u prime. There's an inside function and an outside, so the chain rule, u prime times derivative of ln of u is 1 over u. Okay, so something like the derivative of ln of x, derivative of x is just 1 times derivative of ln would be 1 over x. Okay, so some examples. Derivative of the inside is 2 times derivative of the ln is 1 over 2x. The 2's cancel, you get 1 over x. The second one, derivative of the inside is 2x times derivative of ln 1 over x squared plus 1. So you can write that 2x over x squared plus 1. Okay. Here, when it's x times ln of x, that's a product. You still need to use those rules. Okay? Derivative of the first is 1 times the second, plus the first times derivative of ln of x is 1 over x. The x's cancel, so you get ln of x plus 1. With the last one, derivative of the inside is 1 over x times derivative of the outside is 3 ln of x squared. So 3 ln of x squared all over x. Okay. Now, these ones, sometimes it makes sense to use the log properties first to simplify. Sometimes it doesn't. It's totally up to you. The first one, I would just do this straight out. Derivative of the inside is 3x squared minus 2 times derivative of the outside, 1 over x cubed minus 2x plus 1. So your final answer would be this. Okay. Something like this one. I would rewrite that. It's ln of x plus 5 to the 1/2. So that would be 1/2 ln of x plus 5. Okay, so when you do that derivative, 1/2 is just the constant, so it stays there. Derivative of the inside is 1. Derivative of ln is 1 over x plus 5. So you get 1 over 2 times x plus 5. With this one, I would rewrite it and do the derivative separately. So ln of 2x minus ln of x minus 3. So derivative of the first, derivative of the inside is 2 times, derivative of 2x is 2, and then derivative of ln is 1 over 2x. This pen is not working great right now, sorry. And then minus the derivative of x minus 3 is 1 times 1 over x minus 3. So you get 1 over x minus 1 over x minus 3. Okay? Yes, you should get a common denominator there. Okay? You can multiply, let me change color so you can see it. Multiply by x minus 3 and multiply this side by x. So let me move this one down and erase this. Now we're back. Okay, so you have x minus 3 over, well, then minus x, all over x times x minus 3. X and negative x cancel, so negative 3 over x times x minus 3. Okay. This one right here, I would split it up versus doing the product rule. Totally up to you though. Ln of cosine of x plus ln of sine of x. So the first one, derivative of the inside is negative sine times 1 over cosine plus derivative of the inside here is cosine times 1 over sine. So this is negative sine over cosine, which is negative tangent. And then cosine over sine is cotan. So negative tan x plus cotan of x. Okay. With this one, just like the one above, bring the 3 down in front. So you're going to have 3 times the derivative of x minus 3 is 1, times derivative of ln is 1 over x minus 3. So you just get 3 over x minus 3. Okay. So the next piece is derivatives involving absolute value. It's the same thing. All right. With these ones, you just do the derivative of the inside times 1 over the derivative of the outside. Same thing. So f prime of x equals derivative of cosine is negative sine of x times 1 over cosine of x, or negative sine x over cosine of x, or negative tan of x. However you want to write that. Okay, now the reason why, alright, I suppose I should explain that. Sorry. So basically, when you have an absolute value, f of x right here equals ln of x if x is greater than 0, or it's the ln of negative x if x is less than 0. Now, the reason why it's, the way that the absolute value is. How we talked about if it was x, if we talked about if it was x plus 1 or x minus 1, it looks like this. And this, so if this was x minus 1, this line, this first line ends up being negative x plus 1. And then the second line would be x minus 1. That's the same thing, ln of x versus ln of negative x. Now, if you do the derivative up here is 1 over x, if x is greater than 0. And the derivative here, derivative of the inside is negative 1 times 1 over negative x is still 1 over x. So you get the same thing both times, which is why it just equals that. Okay, so when you differentiate a log and an absolute value, it doesn't matter. You can basically pretend they're not there. Okay. Alright, so when you're doing relative extrema, it's the same way. Okay, this is back doing derivatives, so remembering back to chapter 3, relative extrema. You find the derivative. Now it's not writing. Find the derivative. Okay, there we go. Find the derivative. Set it equal to 0. Solve. test your values. Okay, so this first one, the derivative. Derivative of the inside is 2x plus 2. And then times 1 over, so it's just going to be over x squared plus 2x plus 5. Set it equal to 0. When your numerator equals 0, so that's x equals negative 1. Denominator there, that's not factorable. That would be imaginary, I believe. Let's see. Yeah, that would be imaginary, so it's not equal to 0. So you get x equals negative 1. Put it on your number line. If I put in a number like negative 2, that's 4 minus 4, it's ln of 5. ln of 5 is ln of 5 is out here. That's positive. Did I do that right? No. Yeah, hang on. X equals negative 1. Oh, I'm sorry. I'm putting it into here. Putting it into here. Put in negative 2. That's 4 minus 4, 5. Positive on the bottom, negative on the top. So that is negative. And then if I put in 0, positive and positive. So that's positive. So I am decreasing, then increasing. I have a min at x equals negative 1. Okay. So put that in. 1 minus 2 is negative 1 plus 5. So the min value is ln of 4. Alright. So hopefully you got that. I'm not going to do that second example. If you want to do it, your relative min occurs at 1 over e. And it is negative 1 over e is your relative min. Okay, so, but I think the video is long enough. So there you go. That's how you do derivatives of natural logs.